Every time you open a web page or send a message, your data travels across an infrastructure most people never think about. This module makes that infrastructure visible through a single postal system analogy that makes the whole thing obvious. More importantly, it addresses two things that most people have wrong: what the HTTPS padlock on a website actually tells you, and crucially, what it doesn't, and what a VPN actually does, because the marketing around VPNs has created serious misconceptions. By the end, you'll make better decisions on public Wi-Fi at home and anywhere in between. Every time you open a web page, send a message, or stream a video, your data travels across a complex global infrastructure that most people never think about. It leaves your device, passes through your router, crosses your internet provider's network, bounces through multiple servers, and arrives at its destination, all in a fraction of a second. Most of the time, this works invisibly and reliably. But that journey creates multiple points where something can go wrong, where data can be intercepted, or where an attacker can position themselves between you and your destination. The easiest way to build a mental model is the postal system analogy. Your device is a house with an address. That address is its IP address. Your router is the local post office. Data is broken into envelopes called packets and sent separately, each routed by the postal system to the right destination. The phone book that translates names to addresses is the domain name system, DNS, and HTTPS is like sending your letters in sealed, tamper-evident envelopes that only the recipient can open. HTTP is like sending postcards. Anyone who handles them along the way can read them. 5 concepts appear constantly and are worth having a clear mental model for. An IP address is a unique number assigned to every device on a network, like a postal address for data. IP addresses are logged by every website and service you visit and can identify your approximate location. DNS translates human-readable website names, like google.com, into the numerical addresses computers actually use. DNS requests are often unencrypted, which means they can reveal which websites you visit to your internet provider or any network observer, even if the websites themselves use HTTPS. A router connects your local network to the wider internet. A compromised router can intercept or redirect all traffic passing through it. Home routers with default passwords are a common attack target. Packets are the small chunks that data is broken into for transmission across the internet. Unencrypted packets can be read by anyone on the network path between you and the destination. HTTPS encryption makes the contents unreadable, even if intercepted. A protocol is the set of rules governing how computers communicate. Insecure protocols expose data. Secure ones encrypt it. When you visit a website, it uses one of two protocols, HTTP or HTTPS. The difference is fundamental to your security. HTTP sends data in plain text. Anyone on the network path between you and the server, your internet provider, a router you pass through, someone on the same Wi-Fi network can read the content. Any credentials you type, any form you fill in, any page you load is visible in plain text. In 2024, using HTTP for anything that involves personal data or login credentials is indefensible. HTTPS, the S stands for secure, encrypts the connection between your browser and the server. Even if an attacker intercepts the data packets, they cannot read the contents. The padlock icon and https:// in your browser's address bar confirm an encrypted connection is in place. Now, the important correction, and this is one of the most common misunderstandings in consumer security. A padlock does not mean the website is trustworthy. It means the connection is encrypted. Criminals routinely obtain valid HTTPS certificates for phishing websites. The site fakepaypal.com can have a padlock just as easily as paypal.com. The padlock tells you that nobody in between can read your traffic. It tells you nothing about whether the person at the other end is who they claim to be. Always check the domain name, not just the padlock. The domain check from Module 4 applies here as well. The real domain is always the part immediately before the first single slash. A padlock on a fake domain is a padlock on a fake domain. Free Wi-Fi in coffee shops, airports, hotels, and stations is one of the most convenient things the internet has given us. It is also one of the most commonly exploited attack surfaces for opportunistic attackers. The core problem is that public networks are shared. Everyone connected to the same access point is, in a meaningful technical sense, on the same network. Eavesdropping on unencrypted traffic, an attacker passively captures all unencrypted data on the network. Any website using HTTP, not HTTPS, is readable in plain text. Defense: only access sites with a padlock. Enable TPS only mode in your browser. The evil twin access point. An attacker sets up a Wi-Fi hotspot with exactly the same name as a legitimate network, coffeehouse free or airport Wi-Fi. Your device connects automatically. All your traffic passes through the attacker. This is why you should always verify the exact network name with staff before connecting. Not assume the most prominent network in the list is legitimate. Man-in-the-middle attacks. The attacker positions themselves between you and the destination server, relaying traffic while reading or modifying it. Defense: keep your operating system and browser updated and use a VPN on public networks. Network scanning and exploitation. The attacker scans for other devices on the same network, looking for open file shares, unpatched services, or devices using default credentials. Defense: enable your device's firewall. Turn off file sharing when on public networks. The practical rules. Verify the network name with staff. Use mobile data instead of public Wi-Fi for banking or work tasks when possible. Mobile data is significantly harder to intercept than open Wi-Fi. Enable HTTPS only mode in your browser. Consider a VPN for regular public Wi-Fi use, but understand what it actually does, which is what the next slide covers. VPN stands for Virtual Private Network. It is one of the most marketed and most misunderstood tools in consumer security. Understanding what a VPN actually does, and crucially what it does not do, lets you use it appropriately rather than relying on it for protection it cannot provide. What a VPN does: it creates an encrypted tunnel between your device and a VPN server. All your traffic travels through that tunnel. From the perspective of anyone on your local network, a cafe Wi-Fi router, your internet provider, they can see that you are connected to a VPN server, but not which websites you are visiting or what data you are sending. From the perspective of the websites you visit, your traffic appears to come from the VPN server's IP address, not yours. What a VPN does not do: it does not make you anonymous. Websites still track you via cookies, browser fingerprinting, and the fact that you are logged in. The VPN provider itself knows your real IP address. You are trusting the VPN provider instead of your internet provider, not removing trust from the equation. It does not protect you from phishing, malware, or fake websites. A VPN encrypts the road your car travels on. It does not check whether your destination is a legitimate building or a cardboard facade. Clicking a phishing link through a VPN still takes you to the phishing site. It does not protect you from your own decisions. If you download and run malware, the VPN does not prevent it from executing. The bottom line: a VPN is a useful tool for one specific job: protecting your traffic from observation on untrusted networks. It is not a comprehensive privacy or security solution. For work use, The corporate VPN your organization provides is different from consumer VPNs. It connects you to your organization's internal network and routes work traffic through organizational security controls. Follow your organization's guidance on when it must be used. Most people pay careful attention to security on work devices and work networks. Fewer people think carefully about their home network, even though it is the network their work laptop, their phone, and increasingly their smart home devices all connect to. 3 things you should do if you have not already. Change your router's default credentials. Every router ships with a default administrator username and password. These defaults are often printed on the router itself and published in public documentation for every model. An attacker who can reach your router can log in with these defaults and take complete control of your network traffic. Log into your router's administration panel, usually accessible at 192.168.0.1 or 192.168.1.1, and change the admin password and Wi-Fi password if they are still factory defaults. Keep your router's firmware updated. Routers run software that, like any software, contains vulnerabilities. Many routers can be set to update automatically. Enable this if the option exists. A router running 3-year-old firmware is running known, unpatched vulnerabilities. Separate your smart home devices, smart TVs, home assistants, connected cameras, and other Internet of Things devices often have weaker security than computers or phones. Many home routers support a guest network, a separate Wi-Fi that is isolated from your main one. Putting smart home devices on the guest network means that if one is compromised, it cannot easily reach your laptop or phone. And the key habits that translate this entire module into daily practice. Always check for HTTPS, the padlock, and HTTPS:// prefix before entering any personal information or credentials on a website. Enable HTTPS only mode in your browser settings. Chrome, Firefox, Safari, and Edge all offer this. It forces encrypted connections and warns you when a site tries to load over HTTP. Verify the exact Wi-Fi network name with staff before connecting on public networks. Use mobile data instead of public Wi-Fi for sensitive tasks when possible. Change your home router's default admin password and Wi-Fi password if you have not already. Keep your router's firmware updated. Use your organization's VPN when working remotely on an untrusted network, as directed by your IT team. Alright, before we move on, here are the 3 things from this module I want you to hold on to. Number 1. HTTPS encrypts the content of your communication, but the padlock does not tell you whether the site itself is legitimate. Number 2. Public Wi-Fi risks are real. Evil twin networks, man-in-the-middle attacks, unencrypted traffic. Use a VPN for work tasks on public networks. Number 3. A VPN protects traffic between your device and the VPN server. It is not a privacy shield for everything you do online. Now, before you move on, there is one question. You connect to coffeehouse_free Wi-Fi without confirming the network name with the staff. An attacker has set up a rogue access point with the same name. You access your work email over HTTPS. What does HTTPS protect in this scenario? The correct answer is B. HTTPS provides real meaningful protection here. The content of your communications is encrypted and unreadable to the attacker. What the attacker can see is metadata, which websites you connected to, how much data transferred, and when. They cannot read your emails or capture your passwords. This is why HTTPS matters. But it is also why a VPN adds value on untrusted networks by hiding even that metadata. Next up, Module 8. Who are the attackers? See you there.